So let us take the analysis of cable subjected to concentrated load. We have seen analysis of cable subjected to UDL, at which I have told the shape of the cable will be parabola. Even at same level, at different level, already we have worked the problem. Whereas here, in the case of cable subjected to concentrated load, the shape of the deflected curve will be in the polygonal form. That is regular polygonal form. So you can say the shape of cable subjected to concentrated loads will be a polygon, a funicular polygon. It's a funicular polygon. That's all. Suppose if you take a cable, then the shape will be in this fashion. This is called funicular polygon when it is subjected to concentrated loads. Each point where it is subjected to concentrated load will deflect by different amounts, and the ends are simply supported or hinged, suppose like this always. And when they are subjected to loads like this, say W1, W2, W3, supported at the ends which are at same level, having a span of L, and so these deflections will be Y1, Y2, Y3. This shape will be called as funicular polygon shape. This is a sort of bending moment diagram, in other words, for this particular loading. If you treat this as a beam subjected to concentrated load, then the shape of the bending moment diagram will be called as funicular polygonal shape. And this shape itself will be polygonal shape. It is bending moment diagram itself. Funicular polygon or shape of that bending moment diagram of this. So while this is of shape of a bending moment, so the bending moment at any point when it is of same shape, so it will be 0. That means cables are always subjected to only axial tensile force, and there is no bending moment at any point. The bending moment at any point will be actually compensated by the reaction developed and horizontal reaction developed at the ends. Here there is a horizontal reaction, two horizontal reactions developing equal and opposite. Like this is HB, this is HA, and HA is equal to HB. Always, if you apply sigma H equals 0, when they are subjected to only vertical load, then H is equal to H. And this H will, because this cable undergoes sagging, so it gives a moment, and this moment is exactly balanced the vertical beam moment which is developed on account of the vertical reactions and also the loads. So exactly the bending moment at any point, it will be 0. So you say the cable is subjected to only axial tension, and there is no bending moment at any point. That's why the shape itself is the bending moment diagram or funicular polygon. That you have to understand first. So you consider a cable subjected to concentrated load like this, spanning L. So as I told you already, there are problems will be of two types. One, for finding if the length of the cable is given, then you have to calculate the depth. Or in other words, you have to find the profile of the cable. So that is first. Otherwise, if they give this depth at any one point, at other points also we can find out what the deflection. And knowing that deflection, we can find the length of the cable, as well as the maximum tension developed in the cable. The maximum tension will be always at the two end supports, and that will be equal to square root of that resultant reaction at end support, which is nothing but square root of either VB square plus h square or square root of VA square plus h square. So the maximum tension in cable will be the resultant force at end supports. So that is RA, which is nothing but square root of VA square plus HA square, and RB will be square root of VB square plus HB square. Here HA is equal to HB, which is equal to H and told. So if VA is maximum, then RA will be the maximum tensile force. If VB is maximum, then RB will be the maximum tensile force. So that is how we can determine the maximum force of this. So these points I will call it as D, G, right? Then length of cable will be equal to AC, that we denote by the small symbol L, is equal to AC plus CD plus DE plus EB. So this is the actual length of the cable, obvious. It is length of each of these segments. So which you can determine if you know this, then you can find out if this is equally divided. Each of these span is say L, this L is equal to 4L. Then this AC will be equal to square root of L square plus Y1 square. Then this will be square root of L square plus Y2 minus Y1 square. Like that. You can work out this straight away. If they have not given in the problem the length of the cable, then you can determine the length of the cable like this. If they give the length, then you can find these deflections. So the problem will be finding the length of cable or finding the deflections or profile of the cable along with the maximum tension. That's all. Only two unknowns. One is maximum tension, other is either length or profile of the cable. These are the only two things you have to do in case of analysis of the cable, nothing other than that. And also, if they give whatever the type of support, then probably you may have to determine what is the reaction on that particular supports, and also the moment developed, because horizontal reaction also will be there, moment developed on the end supports. So those are the three types of things which you have to do in the analysis of cable subjected to concentrated. Now straight away you take an example and we determine either maximum tension or length and this. So next problem, 3 nodes of magnitude 15 kilonewtons, 10 kilonewtons and 15 kilonewtons are suspended from a cable or suspended on a cable of length 45 meters at equal intervals respectively, that is 10 meters respectively, as in figure, over a horizontal span, over a horizontal span of 40 meters, over a horizontal span of 40 meters between end supports at same level, So find maximum tension in the cable and the sag at loaded points. So as I pointed out, the problem is of two types. One, length will be given, sag or profile of the cable may have to be determined. Or if profile or in other words sag is given, length you may have to find out. That's all. Of course, tension is the maximum tension that you have to determine for designing the cable, size of the cable. So that's all. Now you take that. So here the cable suspends three concentrated loads of magnitude 15, 15 and 20, 10 kilometers, 15 kilometers over a span of horizontal span between the supports. End supports is 10 meters equally. So total span L is equal to 40 meters.
45. 40.
Length of the cable.
Cable length. Yes, sir.
Cable length is 45,
Yes, sir.
not 40. 40 is the
Span.
this horizontal span of 40 meters
Yes, sir.
between the end supports. Cable length is 45. Then this is cut A, B, C, D, E. That means get this. I'll call it as Y. This also has to be Y only because it is symmetric. Otherwise you call it as YC, YD, YE. This as YD. So we have to find out YC, YD, YE, sag under the points, maximum tension developed in the cable. That's all. So the reactions will be here it is BA, here it is BD, here this is HB, always tensile because cable is subjected to only tension, whereas in the case of arch it is compression, the two things. So first step, so apply sigma H equals 0, you will get HA plus HB. HA minus HB is equal to 0 or HA equals HB, each is equal to H. Each is equal to H, you can say. Like that. Then for finding VABB, you take sigma MA moment about A, 0 either A or B. Then you will get VB into 40, that is equal anti-clockwise, and this Moment due to these slopes are all clockwise. So that is equal to 15 into 10 plus 10 into 20 plus 15 into 30. So due to this, it is 15 into 10. Due to this, 10 into 20. Due to this, it is 15 into 30. Or VB is equal to, this is 150, this is 200, this is 450 divided by 30. So
20.
800
Sir.
divided by 40, it is 20 kilonewtons. So then if you take sigma V equals 0, you will get VA plus VB is equal to 40. VA plus VB is equal to the total load 40. So VB is 20, therefore VA is equal to 40 minus 20, that is also
20.
naturally we can write it as it is because mode is symmetric. So this is how first you can determine the
Reaction.
support reactions. Then we can find out TA, TB. TA will be equal to square root of VA square plus HA square, that is equal to, or HA you have not yet determined.
Yes,
You
sir.
cannot determine that HA unless you know the
Exactly.
profile. That we will take up next after finding the profile BA and all those things. That is only exercise. So next we will determine the profile or the sac. So you can say let y equals yc, that is equal to sag at point C. You can call it. Then you can find out bending moment at C. And MC is equal to that BA into 10. That's a B moment. So I have not taken H. I told you already with any point, at any point bending moment is 0. So that bending moment is 0 because of the bending moment generated by the horizontal thrust. So first I will take MC is equal to VA into 10. So VA is nothing but, that is 200. Then MD, that is also, that is VA into 20, that is 20 into 20, 400, this is 200. Then ME, that is equal to VA into 30 or VB into 10, either one you can take it. So that is 20 into,
So that is
oh sorry,
15.
this is 20 into 20 minus that 15 into 10.
Yes, sir.
So that is 400 minus 150, that is 250. So here it is 20 into 30 minus 15 into 20 minus 10 into 10. So that is also 200. It has to be. So or if you take VB into 10, that is 200 only. This is what you have to determine. What is the bending moment? Treating it as a beam only on account of vertical reaction. Then you can find out that Y is nothing but that particular point, that is YD is nothing but, Y is the deflection I have told at point C. At point D, YD is given by this YC into bending moment at D divided by bending moment at C. Right? So this is nothing but YD is equal to YC into MD divided by MC. So this is nothing but 1.25 YC, or that is 1.25 Y. Then YE is nothing but yc into 200 divided by 200. That is ME divided by MC. So that is again it is yc itself, that is y. So y equals yc, yd is equal to 1.25y and y is also y. So therefore you can find out the length of each segment. AC is nothing but square root of, that is 10 square plus y square. Correct? Yeah? 10 square plus y square, that square root is this. You see, that's what I told. We are determining the profile, that is sag. So that is nothing but square root of 100 plus y square, or this you can write it as 10 into 1 plus y square to the power of half. Similarly, AC, CD. CD is nothing but square root of 10 square plus 1.25 y minus y whole square. Here, this yd minus yc whole square you have to take. That you have to be careful. So this is nothing but 100 plus this is 0.25 y square. That is 0.25 square. 0.25 square is 0.625 y square. Correct? Huh?
Yes, sir.
And or this you can write it as 10 into 1 plus 0.625 divided by 100. That is 0.00625 y square to the power of half. 0.625 divided by 100. So then D is square root of 10 square plus this is also 1.25 y minus y. For that, DE is equal to this. That is nothing but yd minus ye. Y is also y itself. So it is 1.25 minus y. That is also equal to 10 into 1 plus 0.00625 y square to the power of half.
So that AC also changes, right?
Pardon?
That AC.
Which one?
First one, AC.
Yes.
Square root of 100 plus y square.
Y
We
square.
are taking 10 outside. So 1 plus
Ah.
y square or 1 by
Y square by 10.
Yes, sir.
Okay, correct. So you see, y square by 100, that is 0.01
y
square.
square. Yes, sir.
Correct. Next, ED lastly, that is same as that, 10 into 1 plus 0.01 y square to the power of half. So this is length of each segment. That's the profile. So you add all this because they have given the length of the cable.
Yes.
L. So this sum is 45. From that we can find out y. That's all the exercise, nothing other than that. It is simple mathematical work, nothing other than that. No other derivation, nothing. It is simple, straightforward problem. So then you can find out. Therefore, length of cable equals AC plus CD plus DB plus EB. So length of cable is given as, or this is 45 equals, length of cable is given. You take 45 is equal to, you take all these. That is equal to, first AC is 10, that 10 I will take it outside. Here each of these things I have 10. I will take it outside. I will get 10 into 1 plus 0.01 y square to the power of half plus 1.00625 y square to the power of half plus 1 plus 0.00625 y square to the power of half plus 1 plus 0.01 y square to the power of half. So now this y is less than this span. It is very small. So therefore this expansion, whatever is there, 1 plus some x to the power of n, which is nothing but, you can approximate it to 1 plus 1 by 2n. So since y is less than n, we can approximate the above expression as that expansion 45 is equal to 10 into, so this we can write it as 1 plus 0.01 y square by 2. Whatever is that you can take it half 1 by n. So then this you can write it as 1.00625 y square. This you can remember by 2 plus 1 plus 0.00625 divided by y square divided by 2 and 1 plus 0.01 y square divided by 2. That's the only extra approximation you have to remember. Now you can simplify this, or 45 is equal to 10 into this 1 plus 1 plus 1 plus 1. That is nothing but 4. Here I can take y square, common factor, 0.01 by 2, it is 0.005. Correct? Then this is 0.00625 by 2, that is 0.03125. Then 0.03125 plus 0.005. This is 40. Now we can simplify this further, or this is 40. So I will take this side. So 45 minus 40 is equal to y square into this sum.
Into
how much?
So that sum multiplied by 10, it will give
Sum
0.1625.
Huh?
0.1625.
1625 y square. Therefore, y equals square root of this 5 divided by 0.1625.
5.54.
5.54. Correct?
Yes, sir.
Right? Just check once.
5.54 meters.
Square root.
Square root, yes, sir. After square root.
Square root.
5 divided by 0.16.
Okay. If it is all right, you can write, say yes.
Answer 5.54.
54 meters. That's all. So therefore, yc is equal to 5.54 meters. Yd is equal to 1.25 times this. 5.54 into
6.9.
huh?
6.925.
525 meters.
925.
Huh?
925.
5?
925.
925.
Yes, sir.
Then this is, y is also 5.54 meters. That's all you are supposed to return. That's sad we have recommended all the points. Now we can find out h. that is horizontal reaction H, and find out maximum tension developed in the cable. That's all. So therefore H J, which is nothing but H, which is nothing but M, or that, how to take it, MA divided by YC. Correct? MA is due to that VA automatically. MA is how much we have calculated? MA is that is 20 into 10, 200 divided by 5.4. So, how much?
36.1.
36.1. 9.
110.
13, yeah.
1.
Huh?
1, that's also.
1
Ah.
kiloton. So therefore, so if you want, you can check the same value you will get MB by YD. This is not MA, this is MC. MC, belly moment at the point C.
Right.
Or we can work out VA into 10 meters. You take moment about that C point, you will get that. C point or D point, you will get same H. You can cross check. MD is 200 and how much? 250. 250 divided by that 6.925. You get the same thing.
36.1.
Same thing. Of course, Y it has to be same. That is 200 itself. All you will get the same horizontal reaction. Therefore, PA is equal to square root of PA square plus H square. That is equal to 20 square plus 36.1 square. Similarly, TB is DB square plus H square. That is also same thing. Plus 36.1 square. Therefore, maximum tension is either T or T, whichever is maximum.
41.26.
Huh?
41.26.
41.
0.26.
41.26. That's all. That's what it has been asked here. Length of cable is given. Find which are the same level. Find the maximum tension in the cable and the sag at the loaded point. Sag at the loaded points have determined this activity. Or if they give sag in that length they will not give. Again, you have to do the same calculation. Calculate the AC, CD, and R, add it, you will get the total length of the cable. So, but for this, there is nothing. So, this is about the analysis of cable under concentrated load. UDL, of course, it will be bad shape, it is parabolic. Equation is y equals 4hx squared by s squared L minus x, where h is at maximum sag. If they are at different level, you have to take the origin at this point. You have to analyze it. Absolutely same type of problem. Their length of cable, I have given you the formula. When they are same level, it is 8 by L plus 8 by 3 h squared by L. For different levels, I think L plus 2/3 something I have given that you can remember and calculate. That L1, L2 you have to calculate when they are at different levels. But for this, there is nothing in this particular chapter, analysis of cable. It's a very simple, straightforward thing. Both cables as well as arch.